Hello, this is Mr. Collier, and today we're going to be using the cosine rule. So here's the cosine rule: a squared equals b squared plus c squared minus 2b cosine a. So notice if we look at just this part, it looks kind of like the Pythagorean theorem. So it works very similar, except we got the extra bit. And just the main thing to note here is that this a corresponds to this angle right here. Okay, so that's the corresponding angle. So use this version of the formula if you're trying to find a missing side length. And this is the same formula rewritten, and we use this when we want to find an angle. Okay, so let's see how we use this. Okay, in this example, we've got an angle sandwiched in between two side lengths that we know. That's when we use the cosine rule, and we can use the cosine rule to find this side length over here. I'll call it x, or we'll call it BC. So we can use the cosine rule, and we're finding missing side lengths, so we use the first version. So a squared equals, in this case it's a squared equals b squared plus c squared minus 2 BC cosine angle A. Okay, cosine angle A. So, let's call this A actually, because it's opposite angle A. So we have a squared equals, and now b squared is 7 squared plus c squared is 3 squared minus 2 times, we'll just label that b, and this is c, 2 times 3 times 7 times cosine 35. Okay, so we can work that out. Actually, we can do the square root right now. We have a equals the square root of 7 squared plus 3 squared minus, let's just write it out, 2 times 3 times 7 times cosine 35. So we can do it all in the calculator on one step or a couple of steps. I'll do it in a couple steps. So 7 squared plus 3 squared minus 2 times 3 times 7 times cosine 35. Okay, and that's what we get, but we need to square root it, so I'm going to press second function and the square root symbol, and second function and answer, and I get 4.86, which makes sense. So BC is about 4.86 centimeters. Okay, the next example, find the size of angle R. So this one right here. So we're looking at angle R. We have these two side lengths and the opposite side length. So this is a classic cosine example. We're finding the angle, so we're going to use cosine A. Cosine, and this time it's not A though, it's going to be R. Cosine R equals, and we have b squared plus c squared minus a squared. So notice this angle and this angle are the same in the formula. So when I do this in the formula, then I need minus r squared here. Okay, so let's call this r, this q, and this p. This angle and this side length have to be here and here in the formula. Okay, and then the other two go in this part of the formula. And then we have divide by 2bc, which in this case, which means the two angles that are not opposite the angle we're looking for. So that would be, or two sides that are not opposite the angle we're looking for. So that would be these two sides. Okay, P and Q. So let's actually just put in P and Q. So 2PQ. So now we have cosine R equals, now P squared is 4.2 squared. And then we've got 6.9 squared minus 4 squared out of 2 times 4.2 times 6.9. Okay. Alright, so let's just work that on the calculator. I'm going to make it look exactly the same as that, using alpha and then y equals, and I get the fraction function there. So 4.2 squared 6.9 squared minus 4 squared in the numerator, then 2 times 4.2 times 6.9, and I get 0.8497. So that's 0.8497. Okay, so that's 0.8497. That's cosine r. We want to find r. We have to do inverse cosine of 0.8497. Okay, so we can do that on the calculator and use the exact number on the calculator. We can do second function inverse cosine. Second function, get the answer, and then press enter. We'll get 31.8. So that's 31.8 degrees.